Electricity, a journey through the wonders of the invisible force. Introduction. Electricity is a fundamental force of nature that has shaped the modern world in ways unimaginable just a few centuries ago. It is a form of energy resulting from the existence of charged particles such as electrons or protons, either statically as an accumulation of charge or dynamically as a current. This invisible force, harnessed and understood over time, has become an integral part of our daily lives, powering our homes, industries, and technologies. In this journey through the wonders of electricity, we will explore its discovery, its various forms, and its profound impact on human civilization. Chapter 1. The Origins of Electricity. The story of electricity begins in ancient times, with observations of naturally occurring phenomena such as lightning. The ancient Greeks, notably Thales of Miletus, documented the static charge created by rubbing amber with fur. However, it was not until the 17th century that significant progress was made in understanding and harnessing this mysterious force. The breakthrough came with the experiments of Otto von Guericke, who, in 1670, constructed the first electrostatic generator. This device, known as the hailstorm generator, consisted of a large sulfur ball, turned by a crank, producing sparks when a hand was placed against it. This marked the beginning of systematic investigations into the nature of electricity. Chapter 2. Benjamin Franklin and the Lightning Rod. One of the pivotal figures in the history of electricity is Benjamin Franklin. In the mid-18th century, Franklin conducted his famous kite experiment, during which he flew a kite in a thunderstorm and demonstrated the electrical nature of lightning. This experiment led to the invention of the lightning rod, a device designed to protect buildings from lightning strikes by conducting the electrical charge safely to the ground. Franklin's work laid the foundation for understanding the similarities between static electricity and lightning, contributing significantly to the development of electrical science. His famous saying, "Electricity is a kind of fluid substance," captured the prevailing understanding of electricity at the time. Significant leap forward in the practical application of electricity and laid the foundation for the development of batteries, which would play a crucial role in the later electrification of society. Chapter 4. Faraday and Maxwell's Electromagnetic Revolution. The 19th century witnessed a series of groundbreaking discoveries in the field of electricity and magnetism. Michael Faraday, a self-taught British scientist, made pivotal contributions to the understanding of electromagnetic induction. In 1831, he demonstrated that a changing magnetic field could induce an electric current in a wire, laying the groundwork for the development of electric generators.